Okay, so what we were doing before I cut off in the last screencast, we were using these rules here, along with our trigonometric identities, sine squared plus cos squared equals 1 and tan theta equals sine theta over cos theta. So we're using those to answer this question here. So if sine of theta equals square root of 3 on 2 and cos of alpha equals 4 on 1, then we had to find the values of some following things. So we did this one, this one, this one, and I think I cut off in the middle of this question here. So we're asked to find tan of 180 degrees minus theta, and we should remember that tan of an angle is equal to sine of an angle divided by cosine of that same angle. So that is just that trigonometric identity that we revised right way back at the beginning. So we need to find sine of 180 minus theta, and we need to find cosine of 180 minus theta. Now, we're given, as I said in the original part of the question, we were given that sine theta equals the square root of 3 on 2. We should remember that if we think about 180 being pi, so this is the same as sine of pi minus theta. So that's in the second quadrant. Sine of pi minus theta is just equal to sine theta. And while we're at it, we also need to know what cosine of pi minus theta is, and that's just negative cosine of theta. So sine of pi minus theta is sine of theta. Cosine of pi minus theta is minus cosine of theta. Now that was value given to us in the question. And if you remember, we have already, in question C, we already worked out that cosine of theta is equal to plus or minus a half. However, for 180 minus theta, we're in the second quadrant. In the second quadrant, cos is negative, so we need to take the negative value here, so negative a half. So now that we've got sine of 180 minus theta and cosine of 180 minus theta, we can work out what tan of 80 minus theta. So we just put in our sine of theta, sine of 180 minus theta, which is the square root of 3 on 2, divided by our cosine of 180 minus theta, which was minus 2. Remember that when we divide by a fraction, that's the same as multiplying by the inverse of that fraction. Oops, and I've somehow gotten rid of a negative there. So that should be negative the square root of 3. I should have had, kept the negative here and carried it down here, which makes sense because we should have a negative tan value in that quadrant. So this should be negative the square root of 3. Okay, so you should be able to answer question 2 from 1.3. Okay, so what we're going to do now is use our exact values, the special values that we have in that table that I gave you that I asked you to remember. We're going to use those values to help us find larger angles or smaller angles that exist in the second, third, and fourth quadrant. So what we're going to do is we're going to sketch those angles out. So say we were asked to sketch 5/6. So 5/6 would be that whole angle here. We measured from the positive x-axis. That would be 5/6. And then we're going to calculate the reference angle. So the reference angle or base angle is the angle that is between the x-axis and the line that we draw to represent our whole angle. So if this was 5/6, then this would have to be 1/6 here. So our reference angle in the first quadrant, or our base angle in the first quadrant, would be 1/6. Okay, so if we're asked to give exact values for each of the following trigonometric expressions, so these are just examples from the textbook. So the first is to find the exact value of cos of 2 pi on 3. So 1 pi is half a circle, so we would divide it into 3 sections, 1, 2, 3, and draw 2 pi. So that's 1, 2. So 2 pi takes you into the second quadrant. The reference angle, the angle between x and this angle, is just 1/3. So our cos of 2 pi on 3, which is exactly equal to pi minus pi on 3, we know that in the second quadrant cos is negative, so we just find cos of that reference angle, and our reference angle of course was pi on 3. So from exact values we know that cos of pi on 3 is a half, so this has to be negative a half. Next one, tan of 7 pi on 4. So we need to divide pi into 4 equal quarters. 1 quarter, 2 quarters, 3 quarters, 4 quarters. We need 7 quarters. 1, 2, 3, 4, 5, 6, 7. So that puts us in the fourth quadrant. In the fourth quadrant, tan is negative. Our reference angle, if that's 7 pi on 4, our reference angle here has to be pi on 4. So what we need, if tan is negative, we need to find negative tan of pi on 4. Tan of pi on 4 is 1. So that makes our answer negative 1. Cos of negative pi on 6, negative pi on 6, we have to go in the clockwise direction from positive x-axis. So that'll put us only 1/6 in this direction. So we're in the fourth quadrant. Cos is positive in the fourth quadrant. If this angle here is pi on 6, so our reference angle is pi on 6. So cos of negative pi on 6 is the same as cos of pi on 6, which is equal to square root of 3 on 2 from our exact angle table. So have a play with questions 5 and 6 from 1.3. So notice I've missed 3 and 4, but we're going to come back to them and do them next. So far we've got a set of rules that help us to consider angles that are relative to the x-axis. So we've got pi minus theta, pi plus theta, theta, and 2 pi minus theta. So now what we're going to do is we're going to consider angles that are relative to the y-axis instead. So we're still going to have our base angle theta that's in the first quadrant here, but we're going to consider the angles, because this is pi on 2 here, we're going to consider pi on 2 minus theta, pi on 2 plus theta, and round here 3 pi on 2 minus theta and 3 pi on 2 plus theta. So don't forget that our x value is cosine of theta and that our y value is sine of theta. So again, that looks a little bit like this in the first with our reference angle. So cosine is the x coordinate, sine is the y coordinate. Now if we consider an angle of exactly the same size theta, but measured from the y-axis, this triangle is exactly the same as this triangle here. So if this distance here is cosine of theta, then this distance here has to be cosine of theta. If this distance here is sine of theta, then this distance is also sine of theta, except that it's in the negative x direction, so we end up with negative sine of theta. So say for instance we want to find sine of pi on 2 plus theta. Now sine, we remember, is the y coordinate of that angle. So if we have a look here, here's our angle, this is our sine of pi on 2 plus theta. The y coordinate of that angle is cos of theta. So we get this relationship, sine of pi on 2 plus theta is equal to cosine of theta. Oops. Similarly, if we're finding cosine of pi on 2 plus theta, so this angle here, it's the x-coordinate, and the x-coordinate of this angle is minus sine of theta. So you get the rule cosine of pi on 2 plus theta is equal to minus sine of theta. So just putting an example there, say for instance you're asked to find sine of 2 pi on 3. So sine of 2 pi on 3 would put you over here. The y-coordinate of that value can be calculated from our reference angle. So if this full thing here is 2 pi on 3, then this angle that's in here is pi on 6. So if we look at our angle in the first quadrant, sine of pi on 6 is a half, cosine of pi on 6 is the square root of 3 on 2. So this length here has to be the square root of 3 on 2, and this length here has to be negative a half because we're going in the negative x direction. So if I asked to find sine of 2 pi on 3, that's just the cosine of whatever this angle is here, and that angle is pi on 6. So cosine of theta is the square root of 3 on 2. Similarly, if we were asked to find the cosine of 2 pi on 3, in this format, it's equal to negative sine of this angle here, which we've just said is pi on 6, and negative sine of pi on 6 is negative a half. Tan is going to be equal to y on x. Our y-coordinate for tan of pi on 2 plus theta, our y-coordinate is cosine of theta. Our x-coordinate is minus sine of theta. You should note that that's kind of like our identity for tan. Our identity for tan is tan of theta equals sine of theta and cosine of theta. This is cosine of theta on sine of theta, which is just the inverse of tan. So we just write that as negative 1 on tan of theta. So we continue with the argument, we can find these rules. So in the first quadrant, if we're looking at this angle here, which is pi on 2 minus theta, it's equal to cosine of theta. Cosine of theta, as cosine of pi on 2 minus theta is equal to sine of theta, and tan of pi on 2 minus theta is equal to 1 on tan of theta. So there is a pattern. So basically, if we're measuring things from the y-axis, our sine is changing to a cosine, and our cosine is changing to a sine, and our tan is changing to an inverse tan. We can still determine whether it'll be positive or negative based on cast. So of course, in the first quadrant, they're all positive. In the second quadrant, only sine should be positive. In the third quadrant, only tan should be positive and the other two negative. In the fourth quadrant, only cosine should be positive and the other two negative. So they're another set of rules that you have to learn off by heart. But if you remember the pattern, it shouldn't be too hard. Okay, so we'll go through some examples from the textbook. So we're given that cosine of theta equals 0.5300, and we're told that theta is in the first quadrant. It's important to know that theta is in the first quadrant because then we can use our reference angle. So we're asked to find sine of pi on 2 minus theta. You can look at our rule here. Sine of pi on 2 minus theta is equal to cosine of that theta. Equals cosine of that theta. We are given what cosine of that theta is up here. So sine of pi on 2 minus theta is just equal to 0.5300. You can think of that in another way. We could have sketched out that angle there pi on 2 minus theta. That would put us in the first quadrant. In the first quadrant, we're dealing with positive cosine of theta. Next one, cosine of 3 pi on 2 minus theta. If we sketch that out, 3 pi on 2 is here, minus theta. That puts us in the third quadrant. In that third quadrant, tan is positive. Oops, not tan. Yes, tan is positive, which means that sine is negative. Cosine is, tan is positive, which means that cosine is negative. When we're dealing with angles that are referenced from the y-axis, of course, a cosine becomes sine. So we need to find what sine of theta is. We can find what sine of theta is from this cosine value that they've given us up here. So we're using the trigonometric identity, sine squared theta plus cos squared theta equals 1. I've rearranged that just as we did in previous questions so that we can find out what sine of theta is. Sine of theta then is equal to the square root of 1 minus cos squared of theta. We know what cos squared of theta is because we're given it in the question originally. We just place that value in, evaluate it on your CAS, and you should find that sine of theta equals 0.8480. Now note that I'm sticking to 4 significant figures because we're given 4 significant figures in the question. So if sine of theta equals 0.8480, then negative sine of theta must be negative 0.8480. So this time we're asked to find tan of 3 pi on 2 plus theta. We are in the fourth quadrant, 3 pi on 2 plus theta. Here, cosine is positive, which means that tan is negative. Because we're dealing with a reference angle from the y-axis, tan becomes inverse tan of theta. Inverse tan theta is the opposite of our trigonometric identity. Remember, the trigonometric identity is that tan theta equals sine of theta over cosine of theta. So the inverse of that is cosine of theta over sine of theta. We know cosine of theta because we just calculated it, and we're given it in the question, and we just calculated sine of theta. So cosine of theta was 0.5300, sine of theta was 0.8480. So dividing those through on the CAS and sticking to 4 significant figures, we find that's negative 0.6250. So have a go at questions 3 and 4 now. So it's just using this group of identities here. Okay, so from the blue questions, questions 7, 8, 9, 12, 13 and 14 are also good. Do as many as you need from those questions. I'm going to go through the application questions as well. I recommend that you do them by yourselves. It's absolutely imperative that you do them. If you can't do them by yourself, then come back and I'll show you how I do them.